Hi guys. Um, all right, so it is day 6 for your packets, and today should be the first instructional video I give you. Just a few side notes. You all know I am not very tech savvy, so please be kind. I currently am just working with my cell phone, and then I just have this dry erase board. And as I get some more ideas from other teachers or I find other resources, I will use those. But we'll just have to work with what we have. While I am videoing, I want to remind you that I have a puppy and he does make some noise sometimes, as well as my cats make some noise sometimes, and I don't have the editing skills to kind of edit that stuff out. So I apologize if you hear it, and if they need anything, I might just have to pause and come back. But hopefully you find it more so funny than you do anything else. So let's get right to it. I have a copy of the work that I assigned you for day 6. The notes I have electronically. So before we left for school closure, we were still talking about the properties of exponents. And we had one more property to go, and we were supposed to take a quiz, which obviously isn't happening, no big deal. But that last property was called power of quotient, which went very, very closely along to the property that you were doing right before break, which was called power of products. So let me grab my markers. All right, so before we left, let me get a little closer to that board. We were talking about power of product, or also power of powers. So for instance, if I gave you this problem, we know that it's a power of something because we have something raised to a power. And then I told you, like, a really good hint, a red flag of it's a power of something property is if you had a set of parentheses with an exponent on the outside. All right, then I know specifically this was a power of a product because within the parentheses I had terms multiplying. All right, and our steps with this were we were going to keep each of our bases the same and then distribute the outside exponent to all inside exponents. So first, let's identify how many bases we have. All right, so 5 is a base, x is a base, and y is a base. Now, if you look on 5, it doesn't appear that it has an exponent, but it does, and we'll get to that. So our first step was we needed to keep all of those all of the bases the same. And the second step was that all of the exponents would change because the outer exponent would be distributed to each of our inside exponents. So let's get back to this 5. I said it doesn't look like it has an exponent, but it does. So 5 has an exponent of 1. So when I multiply 1 by 4, I get 5 to the 4th power. Then I have 2 times 4, which is 8. And then y has an exponent of 1. So it's going to be 1 times 4. So it becomes y to the 4th power. At this point, if you could use any additional properties of exponents, you would do that. But in this case, we don't have anything else that can simplify. So our answer in exponential form would be 5 to the 4th power times x to the 8th power times y to the 4th power. All right, so again, this was what we did right before school closed. In your new set of notes for day 6's work, it was talking about the quotient. Nope, I take it back, the power of quotient properties. So let's change this. The power of quotient property. All right, and with this property, our steps are very much the same. So I have something in parentheses. Let's start off kind of small and say I have x to the 5th over y to the 2nd, and that's all raised to the 4th power. So I know that I have to use this rule because I have a power of something, and that's your red flag. Those parentheses are your red flag, and then this outer exponent is your power that something's being raised to. This is a quotient because it's a fraction. Quotient represents division. So our rule says we're still going to keep these bases the same, just like we did with our previous problem, and each of our exponents will be multiplied by the outer exponent. So our 4 would be distributed in just like we did in our power products property. All right, so first step, let's keep those bases the same. So I have x and I have y. Then I have x to the 5th, and again I'm going to multiply these, so I'd have x to the 20th. And then I have y to the 2nd multiplied by 4, I actually have y to the 8th power. All right, my next step would be simplify if there's anything to simplify. As you can see, the bases I have are different, so I can't use any of my exponent properties rule to simplify any further, so this would be my answer. All right. So let's take a look at your assignment. All right, I have all your assignments from your packet right here. So this is the paper that I'm referring to. It's your scavenger hunt. In your scavenger hunt paper, your problems are going to be a little bit more difficult here and there because it requires that you simplify and you use some of your additional properties of exponents. So let's look. I know you don't have these numbered, but let's look at this problem right here, because this gets way down into multiple properties. All right, so I know this is again a power of quotient because I have a power on the outside and the quotient on the inside, meaning I have a quotient raised to a power. So following the rules that we just discussed, we're going to distribute this negative to all of those positive exponents. But again, I have a negative. So if you think back to our lesson when you had Miss Sands, she taught you something about the negative exponents. And I know it's been a few weeks, but if I have a negative exponent, we learned that we could take whatever was negative and move it to the opposite side of the fraction, meaning making its reciprocal, and it would be positive. So if I wanted to go ahead and get rid of this negative now, I could do this little trick. I'm still going to keep everything in my parentheses, but I'm going to move all of the information in my denominator to the numerator, everything in the numerator to the denominator, and then I can have a positive 2. So let's do that. So what I'm doing right now is I'm writing the reciprocal of the given problem, which means that this can now be a positive 2. Pretty simple, right? All right, so now let's get into this problem, which is the meat of what we are trying to learn how to do. So to start, we have to figure out how many bases we have. So just look at the numerator. Don't worry about the denominator quite yet. In the numerator, I have 1, 2, 3. And the I said don't worry about it. And then we're gonna go ahead and follow our rule. I need to come down here because I'm gonna run out of room. So what I would have is 4x and y. Then I'm gonna distribute that outside exponent to all of the inner exponents. Right, so I would have 4 squared, x to the 4th, and y to the 4th. Alright, now I have everything in the numerator taken care of. Let's take care of the denominator. So again, we're going to keep all of those bases the same. So I'd have 2, I'd have x, and I would have y. And I'm going to take my outer exponent and distribute it to each of my inner exponents. So I know that looks super crazy, but just follow the red. So I'd have 2 to the 2nd power, x to the 8th power, and y to the 4th power. Alright, so far I've taken care of my power of quotient. I don't have to worry about that rule anymore. Now, on our other problems, we were just finished. But if you look here, we have some things that can simplify. So we can clearly answer these two coefficient problems. We can get these out of exponential form because we know what 4 squared is and we know what 2 squared is. So let's do that. So I have 16 and then I have 4. Alright, and I'm going to mark out things as I go because it's getting a little crazy. Alright, now if I go to my next set of information, see how I have x and I have another x? This brings us to the quotient of powers property, which tells us, excuse me, my neighbor you can hear right now. Alright, so, I lost my train of thought. So quotient of powers tells us that if I have the same base in the numerator and the denominator, I'm going to look at the exponents that I have. Alright, I'm trying to wait for that motorcycle to get, there we go. Alright, so hopefully you can hear me now. Alright, so again, same base, look where your bigger exponent is, which is in the denominator, and that's where we're going to keep the base and subtract the exponents. That should sound familiar to you. So I have 8 minus 4, which becomes 4. And I have simplified my bases of x. All right, now look, you have the bases of y as well. So we're going to do the same thing. Look for where your bigger exponent is, but we end up coming into a problem. They're the same amount. So remember, anything divided by itself is 1. Well, if I have 4 y's in the denominator and 4 y's in the numerator, each of those is going to cancel out, meaning it becomes 1, and we don't have to write 1. All right, so we are super close to being finished. The last thing, notice how I have a 16 and a 4. Well, that can reduce. 16 divided by 4 becomes 4 in the numerator because 16 is larger. So in the denominator, all I have left is x to the 4th. All right, so I know that was a little crazy, but your answer becomes 4 over x to the 4th power. All right, so that should be one of the more complex problems on this paper, with the exception of some fractions. All right, so the very first problem that you start with, right here, I'm sorry, this is not the best way to video. You're going to do the same thing as what we've been doing. Don't let those fractions mess you up. If you have, the only calculator you have right now is on your phone, just figure out what that fraction is as a decimal and then multiply it by the whole number and see what happens. And hopefully you can convert. If you can't, send me a message and I will see if there's any app that we can get you all to download or find, or anything on the computer that would help with that. But don't let those fractions scare you off. All right, so at this point, I've gone over a couple of examples. I feel like this rule still would be pretty okay with you all, since we did something very similar before we left school. If you have any questions for me, I've already told you before how to contact me, but just as a reminder, the Remind app is the best way to contact me because it goes straight to my phone as a text message, and I can answer you right away, whether it's a matter of, all right, give me a few minutes to get my things, or give you an answer right away. You can also email me. You all should have my email address. If not, log into Outlook, type in Penny Powell, and it should pop up for you. And then Live Grades messaging. Now, Live Grades is acting a little funky just because so many people are on it. So if I don't contact you right away, it's just because I can't open the message until they get a few kinks worked out. All right, so I think that's it. I hope you all are well, and let me know if you have questions.